So, hello everyone. Hope you're having a great day and happy Independence Day to all of you. And thank you for tuning in with Recro today. This is Sana, and I'm a community initiative lead at Recro, which is a developer focused organization wherein we are trying to connect developers' aspiration to the right opportunity by working with the high growth startups like Swiggy, Dunzo, CureFit, Udan, Homelane, and there are a lot more companies whom we are working with, a lot more startups whom we are working with. So today we have with us Sarthak Gandhi and Himanshu Singh. So Sarthak is going to be a moderator for this event. He's also part of Recro and working at Dunzo, client premises, as a senior Android developer. And as a speaker, we are having today Himanshu Singh, who has recently become a Google developers expert, like yesterday. So congratulations, Himanshu. And
Thank you.
he is working with Rumi against a startup, and he's having around 4+ years of experience working as a Android engineer, Android developer. And let's go ahead with the platform. So today we are we are using Airmeet as usual, I would say. And on the right hand side, you can see session. So in this, like we are going to have 3 sessions today. One is welcome, which is going on right now, and then we will be having the presentation by Himanshu, and after which we will be going ahead with Q&A. You can anyway keep on asking the question in between in the question section, but we will be answering the question in the last section, the last Q&A. So after that, you can see raise hand option. So if you are feeling you can come here and ask a question, you will be visible here. You'll be audible. Like you will be coming on the platform, and then you will be asking the question when you're raising hand. And then you can see attendees. So who else is attending this webinar? You can see that. Then you can see chat option. So when you can talk about anything regarding the topic and all those things. And then we are having question section, so you can ask all the questions. Just keep a separation between question and chat so that we can we will not miss out any question from your end. And that's it about the platform. I'll just pass it on to Sarthak so that he can take it over from here. Sarthak, on to you.
Hi guys, my name is Sarthak and I'm working in Recro and I'm working on the client location Dunzo right now as a SE2. So we have arranged this session for like all the Android developers out there. We have arranged sessions before for different, you can say, frameworks. This is the first session that we are having for the Android platform. We were thinking about where to start it from. So I think a lot of people are now using Kotlin in their development, and so just it's an introductory topic, which is the like a very core component of the Kotlin language that we have. Like I have seen that we use it, but we don't know that we are using it. And so to explore it more, we have Himanshu, who will be like taking us through the his presentation and his experience and how to use the Kotlin DSL, which will be a lot more helpful for you in your career and like learning the language. So yes, Himanshu.
Yeah. So, am I live?
Yeah, you got live. You can like yeah.
Okay.
Yes.
Hi guys. So I'll be taking you through understanding the whole process of DSLs, how you can actually create your DSLs. So let me share my screen first. So in this basically session, I'm going to tell you about a theory and a basic practical where we are using Kotlin DSL till now in our Kotlin projects, and how we can write our custom DSLs if we want to. So before starting off the whole session, let me introduce myself. I recently, yesterday itself, I became a Google developer expert for Android. On Mindorks open community, I am a contributor for the blogs. And apart from that, I work as a senior Android engineer in a startup called Rumi. It's a remote company based out of US. So that's basically about it for me. Now let me start off with the session. So in this session, we are actually going to understand DSL. So I'll explaining you what domain specific languages are, where have you been using DSLs till now? If you don't know that it are DSLs in Kotlin, then the main topic which everybody is asking a question for, that why do we need DSLs here? The last part would be much of an explanation how we can write DSLs if we want to. It's not a hard and fast rule that we actually require a DSL, but if you want, you can write it. And we'll be covering a couple of examples at the last, what I have done in my particular project. So that might be helpful for you. But before starting the whole project or the whole aspect of learning DSLs, we need to actually learn about Lambdas. So can somebody explain how many of you guys actually know about Lambdas? So I just got one single input that how we work with Lambdas. So basically in Kotlin, we have a very unique feature, which are actually known as higher order functions. So a higher order function, what it does is, it's a basic function in like a general programming language, but the parameter which we pass can also be a function. So it's like a function taking a function as an input. So this build string function which we have here right now is actually a higher order function. Here, action basically is a function which is going as a parameter to the build string, and it is returning nothing. So that's the reason we have passed unit here. And the whole function, build string function, is returning a string. So if you see the action function, it takes a string builder as a parameter here. So to give you the basic structure of a Lambda function, if you see here, the build string function takes another function which takes a parameter of string builder and it returns nothing. And the overall function build string returns an output of string. So if you see in the body of a function, we have actually used action as a function there. And when we try to use it in a general programming language in Kotlin, let's say in an Android or in your Kotlin project, you just use it like this, right? You use the build string. Inside that, you use something sort of a builder, and that builder is actually used to work as a string builder. The way we have passed a parameter for action, right? So this is how you actually work with it. So here, builder is specifically representing a way of string builder, right? So the build string function is having a value builder, and which we can use to append different types of string. But we can also remove builder here, and we can just use this parameter, right? So this actually specifies the builder which we have, and that is the reason we don't have to write this dot append. So directly we can write like this, right? So this is how we can create a Lambda. So this is a very basic structure how we create a Lambda. But what is actually happening under the hood? So how does a very basic or a very new engineer who doesn't have understanding that how does a Lambda work, right? So how can they actually understand what's happening here? So if we see the build string function, so if I break it down, this is something how it looks like. So this is just a representation. This is not an actual code. But if I have to make you understand, this is what I have to do, correct? So a build string function, what it does is it takes another function as a parameter, and as a parameter, it takes a string builder, the same thing which we created here, right? So the implementation is like this, that we have a build string function. Inside that, we are passing another function. So when we are passing that function, then we are not exactly writing the function name, and we are not showing its parameters. What we directly do is we pass it like this, the builder. So the builder is basically the parameter of that specific another function, which is a tag, which is passed as a function to build string. So here you can see this is how we are doing it, right? Now let's say in the previous use case, what we did was we also removed our builder here, and we used this to access it, right? So when I access this, what happens is that I need to have the access of builder. So in this, what we need to do is, if we want to have an access, I'm just breaking it down to you for in a very basic and a very easy way, that when we have to access this builder, what we need to do is I'll just use an extension function. So the function, some function name, which is a parameter here, I'm creating an extension function there, and I am inheriting the properties of that specific function, right? So that is why we actually use our extension function, correct? Because we won't want to do it again and again, and we want to attach a state property there to a specific function. So in this way, we are actually creating an extension function, and then we are not using the builder specifically now. What we can do is, since we have that property, we will directly use this appends. So all of these things which I have done here, this is just for explanatory purpose. This doesn't have to do with anything Kotlin. I'm making you understand how does this Lambda actually work. So here, to give you a recap, what we are doing is we are using the build string function. Inside that, we are passing another function which has a builder parameter of type string builder, but it doesn't return anything. And inside that, we are using that specific builder to append strings. So here we have created an extension function for that specific some function name. And to inherit the builder, we just use this. So this is what it actually looks like. And now when we use it, this is an actual implementation of a Lambda function in Kotlin. So this is the breakdown, how it works, and this is how it actually looks like. But this is not how we write it. So if you ever write this way, you would see an error coming up because this is not the actual way. So this is how a Lambda functions works, right? So if you remember, we have added an extension function here, right? So if I go next, you could see that we have manipulated our build string function like this. Here you can see we have added this dot brackets here to action. Sorry, it just changed out. So in the build string function, you can actually see this, the action function here, which it takes a string builder as a parameter, now has a dot brackets, which actually means now its properties are accessible by that specific function. So these are known as receivers in Kotlin. So here, receiver means that we can do certain actions on that property or that parameter without writing a specific certain line of codes. So when we have a receiver in a function, we don't write extra line of code to make it on the specific type. So here the type is string builder. So when we have attached an extension receiver, you don't have to write anything else. We can directly use the string builders here using append. So now let's come to the topic which we are talking here, DSLs. So before starting this, let me ask you guys, did you guys understand how Lambda function works?
We can do a poll if they want you to cover it again, or how's it?
Yeah, that would be better.
Okay, it's 50-50% Himanshu.
So okay, I'll go with the better one, the worst one, that I'll explain it again. So it's a needed topic here. So let me share it again.
Actually, 52% they're saying yes. 48% they're saying no.
Mm-hmm. Cool. So I'll explain it again. That would be even better for everybody to understand this. So again, I'll go in a very subtle way. This is a function which works as a lambda in Kotlin. So here we have a function called build string, which takes a parameter of another function. The function's name here is action, and it takes a parameter. So the syntax here is colon brackets with an arrow. So the string builder here is the input type, basically the parameter, and the unit here is an output type. So basically it's a return value. or the return type which we would return from action. And string is basically the overall return value of the build string function. So inside the function, what we are doing is we are creating an object for string builder, and then we are invoking the action here. In that action, which requires a string builder, we are passing that builder and we are returning it as a string. So here in this build string function, the basic fundamental is we are passing a function which takes another parameter and does not have a return value. So that's basically what we did. It's known as a higher order function. And in Kotlin, when we try to use it, we are just calling the function build string. And inside that, if you remember, we had this string builder action function, right? So we are just naming the parameter, or the naming the parameter here as a builder, and then we are attaching the append, which is a string builder property, to that builder. And when we run this actually build string function, you would see something like Himanshu being printed up. So, but this is not actually how we write it. If you remember, in Kotlin, we get this, in which we don't have certain sets like builder and an arrow. We don't have to use it. We can directly use like this append. So if you see on the top, Himanshu with angular brackets, that's the output. And here as well, we are not passing builder specifically. So how we can actually do this in Lambdas? So to break you down in a very subtle way, as I said, that action here is a function as a parameter for build string function, right? So now I have renamed the action function here with some function name. Now the very subtle way again here is build string function takes another function called some function name. In our case, it was also an action previously, which takes a parameter of builder and of type string builder. Now we are using that parameter to append values, right? So this is what we were doing there, but in a very concise way, the very Kotlin way, I would say. This is just a representation. So this is how it looks like, a function inside a function. Now, if you remember, we were not using builder there. We were directly using append, because because we don't want to use the builder again and again as a name type. So for that, what we do is we attach an extension function to the parameter function here. So the parameter function here is some function name, and now we created an extension function. So when we create an extension function, we can replace builder.append with just append, because when you create,
Himanshu?
yeah.
Yeah, so there is one question coming up. Like, the people want to know how an extension function works. Like, how are we able to remove the parameter, like the builder from the extension function? So, do you have like an editor right now where we can show like that we can directly access the
So
object of the
yeah,
function?
no. So the thing is, this one is a representation. It's not the way how we write it. This is what I'm trying to explain it to them.
Yeah, like if they want to like they're a little confused on how an extension function works and how did the builder parameter got removed. That's the
Cool. No, so builder parameter is not removed because of this function. It's just a representation how we can do it. So I'll explain you the extension function first, then I'll explain it to you this. So basically, whenever we do certain things, right? Let's say when we have a string, and when we want to print the length of that specific string, what we do is we just do string dot length, right? So we use dot length as a property to that string. So these, like if you want to convert an integer to a string, what we do is in Kotlin you do integer value dot to string. So these are the properties which we have specifically provided by Kotlin itself. So that's something we don't want to do it, right? Let's say again in Kotlin, if we have an image view, and if we want to load an image, what we do is basic on a generic approach is to use glide. We pass the reference to that image view, and let's say the drawable or the URL which we have. we pass it there, correct? But these are a very traditional way how we were doing in Java and how we were doing in Kotlin, a generic way. But an extension function, what it does is, extension function actually adds additional properties, which as a developer, I want to add. So it's not something Kotlin provides. Kotlin provides a way to create an extension function, but we don't want to do it. So if you have created an extension function, for example, for anything, let's say for even a text, right? To access that value, we use this. So let's say if I'm creating an extension function for image view, I would show it at the last, maybe if I'll try to show it how an extension function is created. But when we create an extension function for certain view types or certain data type, to access that specific data type, we use the this. So this is used to specify that we are invoking or we are using the view type or the data type which has been attached to that extension function. So that is the reason this some function name here is actually being extended to an extension function. So here we would be using its extension function. So the append becomes this dot append, and technically we can omit the this here. So that is the reason we created an extension function and nothing else, right? And to explain you this again, I'm just telling you this. Consider this as a visual representation in your brain. It's not the way how Kotlin works. To explain you a higher order function, this is what I should do. This is how I should understand if you're learning it for the first time. Then it's a very basic and a very easy approach to understand higher order function, a function with a functional parameter. So moving ahead, I'll explain you how an extension function works later in the slides. But this going ahead, let me show you a few things. Fine, is that fine? Just think this as of we are adding, we want to access the properties of some function name, and we don't want to write the some function name again and again. That is the reason we are attaching and creating an extension function here. Just think that as of we just want to access the properties of some function name. And that is why I'm creating an extension function. Don't go into the deep why I'm doing it. I'll explain it to you later. But here builder is a property which we want to access. That is the reason we added extension functions here. And later we can remove builder, because now to access builder, we can use this dot append, and we are removing this here, and we are directly using append. Now, when we have to use it, we just use it directly like this. Build string, we open the curly braces, we use append for all the three, and we print an output as Himanshu with angular brackets. So that's how we actually create a Lambda and we work with it. But to give you a final callback, if you remember extension extfn, which I added the extension function, we don't additionally add a name in Kotlin. I showed it to you because I wanted to explain you how it looks like. But here it's a receiver. So now the receiver is basically on the string builder parameter which we have passed, right? So here what's happening is I have attached a property to access string builder's property. So I'm inheriting the properties of string builder to that string function, to that extension function, right? So that is the reason how we write it. So the updated build string becomes with an action function of taking a parameter of string builder, but of an extension value. Just don't put a lot of thought here. Just think this as of I want to access all the properties of string builder, and I don't want to write additional codes here. That is the reason I am inheriting the property and attaching an extension function there. I'll explain to you once more at last. So this is how we actually update our lambdas and how we create lambdas in Kotlin. So that's the easiest way I try to understand a higher order function and working with lambdas. So here in the build string, I'll give you an overview last time. A build string takes a function as a parameter, and the function's name is action, which takes string builder as a parameter, and it returns nothing. So that is the reason we used unit. And the whole build string function returns a value string, and then we return string builder.string inside the body. So that's how we have created a Lambda function with a receiver. That's it. So what is DSL? So we understood right now how we can create Lambdas. We understood how we can create a Lambda with a receiver, and a generic overview how actually this Lambda function works. Not convincing though, maybe, because I have to explain it again, but this is how we do it. A function inside a function. So what is this hype about DSL? So if you think DSL, it's named as domain specific language. So DSLs are known as domain specific languages. So this is very much centric towards a programming language. In our session today, we are talking about the Kotlin DSLs. So basically the DSLs which we are adding here is only centric or attached to Kotlin. You can't use this with Python. You can't use this with Golang. This is just for Kotlin. So that is the reason it is said domain specific languages. So if you remember, or if you might have used for each when you have to iterate in your list, right? In Kotlin, that's a DSL for you. So that's a provided DSL which has been given by Kotlin. So why should we use DSL? That's a very generic question I get a couple of times whenever I have used DSL in my project with my teammates as well. So DSL's usability purpose is only for two things, if I would have to say in that way. The first usability factor is when you have to attach or make your code more readable, like a more English and English centric, rather than going ahead with a very programmatical approach. I'll explain what do you mean by that by an example later, but it makes your code more readable. But more than that, what DSL does is it helps you to access or use the entire uh, plethora of using things which Kotlin provides you. Like Kotlin provides you a lot of different things to do, right? So all the things or all the properties or all the features of Kotlin can actually be leveraged by DSL. So everything which Kotlin is possible to do can also be done using DSL while making your code readable. So that's a very generic way to do it, generic way to explain why we need DSL. But being said that, it's not a recommended way to do it. I would not say it's a recommended way because it actually depends on your use case if you want to create your own DSLs and make your code more readable. Because if there's a very high need to do it, we should actually do it, or else we shouldn't. Now, in this section, we'll start creating DSLs of our own. We have till now used for each. If you know, we have used something called apply as a scoping function in Kotlin. But now we'll start learning with creating DSLs. Fine. So first, I'll be explaining here infix functions, how we can use infix functions to use or create a DSL of our own. So a DSL is something, again, I'll say it's a very specific to Kotlin. We would be sticking to Kotlin here, nothing else. And in second, we'll use invoke. So invoke is an operator which we use. So I'll be using these two to explain how we can create DSLs. And I will show you practical examples where I have used in my code. Like I have used and created a DSL of my own. But before that, we actually have to understand extension functions, right? So this was a query which people asked. So I'm not going to write a extension function, but I have this in my mind because this is a question people ask. So if you remember this, this is how we write an extension function. Now, sort of, this would explain everything, I think, right?
Yes, go ahead. This will be better, like how an extension function works. And
Yeah. So this is how we have an extension function in Kotlin. If you know that if you have to add two numbers, you can just use a number dot plus and you can pass the second number. So that's a property for integer. So I'll explain this function in terms of extension functions. So here what we have done is, this is a Kotlin provided function. but I'll explain it to you. So we first have to write a type, and then we have to name the extension function. So here the function's type is integer, and we have added a name to that function by passing a dot operator there. Now this plus function takes a parameter number and which is of type int. And now in this function, what we want to do is we want to add these two numbers, right? So one number I'm getting from the parameter, that's the number. But the first number which I want, I can access it using this. So this operator I can use to get the value or get the property or basically the value which I'm accessing on. So let's say if I use it with an example, 10 dot plus 10. So here this would represent 10. Or let's say if I pass 100 dot plus 50. So this would return 100 here because dot. So the first function, the extension which it has been attached to is represented by this in the extension function, and the number is the number which we passed in the parameter. So this would return, if we pass 100 dot plus 50, this would return 100 plus 50, and that's 150, right? And we are using equals to here to keep it as a single line function or an expression. If you would say in Kotlin, we don't explicitly need to write a parenthesis and then we have to return this value. So if we have a single line statement, we can use it as an expression. So that's how actually extension function works. So to use an infix function, the way how we have to create our first DSL, we don't actually write like this, right? What we do is we just add an infix keyword in front of an extension function. So if you remember, this infix is just a new thing here. The rest fun int dot plus the number and return type of this plus number, right? This is basically the extension function which I explained it to you before, couple of slides back. But by adding infix, what it does is it adds the property to the integer, but we don't have to access it using the dot operator. How we can do it 100 dot plus something. How we can use it, just let me show. Like this. Here what we can do is we don't have to use 1 dot plus 2. When we use an infix function, what it does is we can write it as a plain English, 1 plus 2. So this is what I meant by making your code more readable. So if you know that when in a generic English language, when we speak 1 plus 2, or let's say when we say 2 plus 3, we don't say 1 dot plus 2, right? So this makes your code more easy and more suitable to your eyes to understand what's actually happening. So what we actually did here was we used a plus extension function to an integer, and we added an infix keyword before the function. And so to use that specific dot plus extension function or the infix function now, we just use plus between two different integers. So here, 2, which we are passing to plus, we are passing it as a parameter. But now we don't need to use the brackets here. Also, the plus is actually being used on the one number, but here we don't need to use dot. So this is a feature, or this is a domain specific thing which we actually use to create our own DSLs. So this is one way to do it. Now let's see another example of infix. So now I've created an infix function of an extension function called minus, right? So here what I have done is I have attached a minus function, minus extension function to an integer property, an integer type, which takes another integer as a parameter. And then it returns this minus number. So this here again is the number I'm attaching the property to. And if I run the output here, it would be 1 minus 2. So this is again the plain English, how we talk about in English, that whenever we were in our maths class, we used to say 1 plus 2 and 2 minus 3. So that's how we are using that basic English concept here to make our own DSLs more readable, right? So here dot minus or the minus extension function is attached again to 1, and 2 here is the parameter for minus function, the minus extension function we have created. So this is how we can use infix to create our own DSLs. Now let's talk about the invoke operator, which I said I'll be explaining it to you. So in this, consider this example. We have a function class called student, and inside that we have two different functions. First, let me explain it to you: add name and add marks. So in this, what it does is add name takes the name of the user or the student, and add marks basically does is takes the marks of that student, right? Let me go next. Here we have added an invoke operator here, and inside that, if you see, we have passed the student receiver function again. If you see that how we did in the lambda slide, and here we are taking student as an input and returning nothing. We are returning nothing here, so that's the reason we used unit. But the whole invoke actually returns the parameter we have passed, the student function here, right? Now, if I have to create an object of the student class, the traditional way is to do this, right? Student is equals to student object, and to access add name, we use add name like this and add marks like this, correct? So this is how we use a traditional way. But since we are using operator, this is going to be the different way how we can do it. Now we can use student as a lambda here, and now we don't have to use student.addName. Rather than we can use student, we can open our curly braces, and now we can do this. So if you see the difference, here we are adding student.addName, student.addMarks, right? Rather than that, here what we are doing is we are adding student, and inside that I'm adding add name and add marks. So this is not a traditional way. I've just written the traditional way just to mark it, that here when we are using, this is the add name which I was marking the traditional way, and in this as well I'm marking add name as a traditional way. So this is the same step, but now here I don't have to use student.addName and student.addMarks. So this is the DSL way to do it. So if you remember this invoke function here, so what invoke function does is whenever we create an object of a class, the invoke function gets called directly. So we don't have to call it again. It's like a constructor for us, but inside this we are passing the receiver of a student, and we are returning that for the invoke. So that is the reason we are actually able to create a DSL for that in this slide, and we are directly using add name. So if I have to add a different property, let's say add my home address, or I have to add something like this, I can directly use student, and inside this bracket I can use add home address. So I don't have to write student dot add home address again. So this invoke operator can be used as well for a class specifically to create our own DSLs, right? So now I'll show you examples where I did on a practical life use cases. One example I'll show you the traditional Kotlin way, how Kotlin provides us to work with DSLs, and one I'll show where I used on my own project, of Android, correct? So you know this, right? This is how we do in text views, or how we do in Android for any text view, right? So here what we can do is we can set a text using .text, and we can assign a value to it. Apart from that, we can attach a set on click listener there. We can do certain different tasks like a text color or some other properties. So here what we do is we do text view dot something, text view dot set on click listener again and again, right? So to convert this into a DSL, we use apply. So now here you can see I'm using text view dot apply, and inside that I'm getting all the access of text view. and we can just directly use text is equals to this set on click listener and text color. So all these three statements would actually be applied to the text view I'm using apply on. We don't have to use again and again the text views. So this apply is actually provided by Kotlin. We also have a couple of different scope functions, but this is one of them to convert into a DSL in Kotlin. So this is the way Kotlin provides. Now, let me actually use it in one of the examples I have used. So when we have to create a JSON object, if I'm not wrong, this is how we do it, right? First, we create an object of JSON object here. Then we add certain properties like using the dot put, right? So what we do here is in the dot put, we use first the key. So the key here is name and a value. So the value here is Himanshu. It's a string value again. In the second put, what we do is we use age and then we use the value. So this is how we do it. This is a traditional way to create JSON objects. So in my project, what I did was I converted it to DSL, and I'll show it how. So I created a generic JSON class which extends a JSON object. So this would be used to create a JSON object DSL. So that is the reason I added it as JSON object. I extended it with JSON object, sorry. Now I will add a constructor here. So in this constructor, what we are doing is we are passing a receiver of this class JSON which we have created, and this returns itself. And when it returns, inside that block, we call that init block. So if you know what is init block in Kotlin, init block gets called after the primary constructor and before a secondary constructor in Kotlin. So anything which we write in the brackets of JSON is a primary constructor, and whatever we do or whatever we do something with a constructor like this is a secondary constructor. So inside that, what we are doing is we are passing the receiver function of this JSON class here, which returns nothing. So that's a return type of unit. And we are passing this as an empty parameter because here the primary constructor takes nothing. And then we are just calling the init block of this specific class, right? Now, as a function, what I'll do is I'll create an infix generic function here. So this generic function is attached to a string. It takes a value, and inside that we use put this comma value. So this too is actually used for that specific key we passed in this. So the key here is name and the value is Himanshu. Just keep this in mind, name and Himanshu. So here what we have done is the string here is name. So what I'm doing is name dot to, and I'm passing Himanshu here. So now I'm passing put, and in this it's the name and the value is Himanshu. So we created a generic function and adding an infix operator there. So we created generic because we just don't want a specific type to be created again and again. What we can do here is we can pass integer, we can pass string, we can pass double, anything which we want of our own type. Correct? And we added this. So now my whole class actually looks like this, where I have a JSON which extends JSON object. Then I have a constructor, and then I have this string value infix. And when I call this, this is the traditional way to do it. But if I have to use it as a DSL, I'll call this like this, where I call that JSON class, and now I don't use put, the previous one, like JSON object dot put, JSON object dot put again. Rather than that, I have renamed it to 2. So this 2 is basically mapping the key name here to Himanshu and age to 26. So now it's basically a new mapper which I have created. But if you see this in a contextual way, that when you do this, you can still use an apply here, where you can do JSON object.apply, and inside that you can add multiple put with a key and value. But here to have a more open relationship, name to Himanshu, age to 26. It's a mapper which I have created in my personal project, and it keeps my code clean rather than using put again and again. So this is an example which you can create as well. And this is how you can actually create DSLs. Uh, so if you remember this infix function, so this is the infix function here, string dot to, and inside that we are taking a value. So now if you see that specific to is attached to this name keyword, and the value it takes as a parameter is Himanshu, and similarly the 2 is attached to age, and the value it takes is 26. So here, since we are passing a generic here, we can pass a string and integer any type we want. And this is where we use the infix functions on an extension function to create a more open DSL for Kotlin. So I am done, like actually done with this session. So I'm open for questions now. So I'll close the slides. And this is my Twitter handle. If you want to ask anything or you have any questions, you can actually ping me there. Thanks, guys.
So yeah, Himanshu, what there are some questions like
Yeah, I'll just take them. Yeah.
can we? There is one question that can we explain the mapper again? How you made the mapper function?
Yeah, I can do that.
Yeah.
Just a second. So I'll start off with this slide. So if you see this, this is a basic structure or the very basic easy way to do it, where we create an object of JSON object and we put specific values to that object again and again using name, the key, and Himanshu as a value, age as a key, and 26 as a value. But if I see this, this is how the mapper works. I'll be explaining it to you now. So if you see this part, the infix function. So first what I've done is I've created an extension function here. I named that extension function 2, and it is attached to the string. So this string is nothing but the key which we are using here in the put name. So that 2 function I'm creating for this. And I am adding an infix function here. So using infix, if you remember, we don't have to use a dot operator to access the extension function. We can directly write it here, and we can make it a general English statement. So here, if you see, we created a function first, infix function of type generics. Here, I am passing it to a string, and we are passing a value, anything of a generic. And this, we are using this put one, which we had here. If you see this, inside that infix function, put this dot value. This is basically the key, name or age, and the value is the one which we are mapping it to. So I'm mapping the name to Himanshu, and I'm mapping age to 26. That's how the mapper function actually works here. This is my way of doing it. You can actually experiment a different way and maybe come up with it. This is how I do it to keep it more sleek and easy for me to understand. Is it okay?
Yes, they are saying yes. So we have a couple of questions.
Yeah, so I'm open to take questions now.
Yeah, you can also read them. Like the first one that we are getting is can an extension function be used on a final class?
Where is it? I'm just going to the questions once, and I'll read one of them and I'll start. So I don't think we can write actually extension functions for final classes. So that's the answer. I guess Yash asked or someone asked. Tanvir, thank you so much for that toast example which you have used. That's actually very helpful for them. So first is I'm actually not sure we can create a final class extension function because you can't attach a property to it. That is something we can use, right? Why? The Tanvir's question is why we need to use text view apply rather than a scope function. So when using a text view apply, we can actually access all the properties there itself. So Tanvir, apply is also a scope function. So that's what you were asking, if I'm not sure. But this is how you should do if you have to add multiple different properties to text view, because when working with Kotlin, you actually need to access a lot of different properties provided by Kotlin rather than using it again and again. Yes, Arnab, you can use student.apply, add name and add marks. But as I said, I wanted to create our own DSL to show you how we can do it. So that's the reason I did. You can still use apply. I'm not, Tufan Mukherjee asked, I'm not understanding where we have the initialize builder and we get null. So this is an example. You're not going to build and get something out of it, but this is just like, if I would explain, it's just an example how we can use it. So if you are going to build, I might share I have a library built on Lambdas using this own. So you can see how I've used builder there. I'll share the link in this questions link. So you can have an overview on that. Vivek asked, Lambda simplifies the code in overview, right? It simplifies things, yes, but overusing it, it might complicate as well. So if that's how you want to see it, but I say it simplifies your code.
The next one that we
So
uh,
I'm going through.
yeah.
So it's an answer rather than a question. I'm
Yeah.
hoping that like what is it?
So there is one question, does compiler generate classes for extension functions?
Internally, yes. So that is the reason how it understands how we can do it. You can check the Java generated code for that, because that is how it gets attached to it. If you see the Java generated code in Android Studio, you would actually see the generated classes, how we are attaching it. So it's more like a util function, if I would say that. Okay. Now, because in apply, then we get that access of that text view using this. So if you want to understand more about it, if you use apply, right, the scoping function, you would see you're getting the access using this directly rather than again using it. So that is the reason we use apply. Are there any limitations? There is one limitation I can think of, Kalpesh, is that there are two different things if you want to go in that way. There are certain things called utility functions or utility class, how we create a singleton. And then there's something called extension functions. So what happens if this is in terms of extension function? So when we create an extension function, right, we actually attach that property for n number of things. So let's say if I am creating an extension function for fragment, so that extension function gets attached to all fragments in the properties. And since I just need it for one fragment and not all of them, I would rather prefer going on with utility functions and not creating an extension function. So that's how I think it's a limited thing. But again, it depends on your use case. So all use cases defined things has to be there.
So
So
that
I have added a link of my repository in which I've been using how we can actually create receiver type functions.
Awesome.
You can see there for the builder patterns if you want.
Yeah. So, guys, Himanshu has added the link, the GitHub repository, so you can refer that link. It's there in the chat section.
Yeah, I think that's it. I'm not sure.
So there is one question that is left, which is like,
Yeah, the question
we should use inline for extension function if we take function as input. Could you please explain this? Why is this needed?
Where is it? Oh, yeah, one more. Where is it? Can you mark it somewhere? I can't find that question.
I've upvoted it.
it's by Kalpesh Chandora.
Yeah, I got it. We should use inline for extension function if they take functions in. I didn't understand the question. We need inline functions as in. So we can do inline functions, but I didn't understand what the question is. We should use inline for extension function if they take function.
Kalpesh,
So
if you
you
can
can.
just raise hand and you can come here so that we can understand your question.
So yes, I think you can you can create a function, like inline function with a function, so that's not an issue. But could you please explain why this is needed? Yeah, it is recommended to use it, but it's not certain things when you use it. Like, let's say you can directly call it for fragments as well, because it creates a function internally. So you should use inline function, but this is just an explanatory purpose. That's the reason we are going with it. Okay.
Okay.
Any more questions, guys?
Himanshu, can so I'll post the link, Yash, maybe after this session for the
Yes.
slides, so you guys can check that out.
Yeah, you will be
So maybe
sharing
you
this.
can share with the attendees
Sure, we'll send a mail to them.
the slide.
Yeah, with the GitHub link and the slides links as well.
Yeah, works fine for that.
Yeah. So, guys, we have shared a feedback link. So please share your feedback. That would be a really great help, like for us to come back with a better version of the session, I would say. So please do that. It's really, really effective for us. Like if you're giving a feedback, it's really gonna make some impact. Also, we have shared, like Sarthak has shared the links, like for Himanshu and for himself, wherein you can follow him and Sarthak, and then you can follow Recro also for the future webinar information, so that you're very updated on that.
Sure.
Okay, great. And thank you so much, Himanshu, for coming us and sharing your knowledge here with us. And I think everyone is really liking the session. I hope everyone has enjoyed. And thank you so much, guys, for joining us here. And we'll see you for the next sessions. If you're having any other questions, you can obviously wait in social on. Like if anyone is there, we'll come there and we can clear your doubt if you're having any such left here. Thank you so much,
Sure.
Sadhana Himanshu.
Okay. Thank you so much, guys.
Have a great day.
Have a great day.
Bye.
Bye bye.
Bye bye.